Now, please raise your hands. Who does not use two-factor authentication on the main smartphone? Okay, I would say about 5 to 10% of all of you guys are not using two-factor authentication, and that's really good. It means that the major smartphone manufacturers did a great job promoting the security and convenience of two-factor authentication. There are three major mobile developers here, Apple, Google, and Microsoft. And all three companies offer distinctly different approaches to two-factor authentication, protecting Apple's iCloud and Apple ID accounts on one side, Google ID and all the connected services on another side, and Microsoft account on the third side. In this presentation, Apple, the two types of two-factor authentication, they didn't make it easy. Two-step verification versus two-factor authentication. What's protected and what's not? What's three-factor authentication? And how to revoke previously authorized devices. Then we'll discuss Google Android as opposed to generic AOSP Android, which is different. And then we'll discuss Windows 10 Mobile, as well as Windows 10 Desktop and Windows Phone 8.1. Let's start with Apple. There are two distinctly different types of two-factor authentication with Apple. The first type they call two-step verification. It appeared initially in 2013, long before iOS 9 was introduced. In early 2014, there was a major break into a so-called Celebgate, where more than 500 celebrities were robbed of their iCloud photos. Later that year, Apple increased security of two-step verification, and they started working on a different two-factor authentication scheme they named two-factor authentication, which was only released 2 years later in 2015 with iOS 9. iOS 8 users still have to use two-step verification, or they might employ an app-specific password. So let's see what's the difference between the two systems. Now, the most important thing here is that two-step verification and two-factor authentication with Apple accounts coexist. You may enable one or another, but not both on the same account. However, you're still able to choose the older and less secure scheme even now. So what's two-step verification? Apple viewed it as an extra verification step in addition to the password. Now, you can easily steal or social engineer the password. However, if you cannot get the secondary verification factor, then the password is useless. You cannot log into your account, or you cannot do some specific activities with your account, even if you can log in. As I said, it was introduced after Celebgate, where hackers used genuine logins and passwords stolen from celebrities. Now, two-step verification is not a universal solution. It was slapped on top of the existing system with no OS support. So it's kind of an afterthought. It's not a full solution. It's not an all-around solution. It only protects sign-ins to Apple ID account page, sign in to iCloud on a new device or at iCloud.com, sign in to iMessage, Game Center, or FaceTime, iTunes purchases and Apple Store purchases, and finally, if you're going to get an Apple ID-related support from Apple, it protects that too. Now, at the time two-step verification was introduced, it didn't even protect all of that. It didn't protect iCloud. It didn't protect iCloud photos. And that was part of the reason this Celebgate was possible, because iCloud backups and iCloud photos were not protected at the time by two-step verification. Immediately after Celebgate, Apple extended protection of two-step verification to cover iCloud and iCloud photos. What is two-step verification in Apple's view? Two-step verification requires an additional verification code. It's basically a code consisting of 6 digits that can be either pushed to your trusted device via Find My Phone protocol, and we'll talk about it later. It's not a secure way to push it. Or it can be sent as a text message to your trusted phone number, or it can be delivered as a phone call. You can also generate and use application-specific passwords, a unique password that allows certain applications that are not compatible with two-step verification to still be able to log in. Now, these specific passwords, app-specific passwords, they're very limited in what you can do to them. For example, you can use an app-specific password to use IMAP, but you cannot use an app-specific password to log into iCloud or download a backup. Up to 25 app-specific passwords can be active at any given time, and they can be revoked individually. Finally, for two-step verification, you can print an account recovery key, which is a 14-character printable key that you're very advised to have with you at all times, especially when traveling. More on that later. Enrolling to two-step verification is very easy. You can either enable it from your Apple device or just activate it on your My Apple ID account from any web browser. It's different from enrolling to two-factor authentication, which Apple introduced later. Unfortunately, for two-step verification, you have to enroll at least one trusted phone number. And as many of you may know, a trusted phone number is probably one of the least secure ways to receive a secondary password. So why is that? Because a SIM card can be cloned. A SIM card can be removed from a secure iPhone that you may not be able to unlock because you don't know the passcode. So it can be removed, inserted to a different phone, and voila, you get a one-time password. Now, finally, there is a scam going on in Russia where you can use a faked power of attorney to just go to your mobile operator and get a replacement SIM card. And this SIM card will still receive a one-time password. So as I said, SIM card-based two-step verification is not the most secure way to do it. Now, Apple has a second way for two-step verification, which is delivered through Find My Phone. This is not a secure method as well, because Find My Phone is a protocol that was initially developed for delivering messages to locked devices. If you lost your iPhone or if it got stolen, this is Find My Phone protocol that delivers a lock message or that can be used to erase your iPhone. So what's the problem here? The problem is the Find My Phone delivery, the message with a single-use code shows up straight on a locked device. There is no need to unlock the iPhone with a fingerprint or with a passcode or a password, whatever you're using. It's just being shown in plain view. So as you can see, two-step verification uses two different methods for delivering single-use codes. Both are extremely insecure. So this whole scheme can be characterized as better than nothing. And it's not much better than nothing, unfortunately. It was named as the weakest of all the major tech firms two-factor authentication schemes by the Register. And it was back in 2013. So now in 2016, it's obsolete. If you're still using that, consider switching to a newer scheme that is called two-factor authentication. Now, two-factor authentication is a very generic name, and it refers to a general protocol of authenticating with an additional step. Apple used that term to distinguish between the old scheme and the proper authentication scheme. Now, two-factor authentication uses an OS level support to deliver single-time passwords. It doesn't work in any iOS older than iOS 9. It doesn't work in any macOS older than El Capitan. It does require OS level support. It only works within Apple's ecosystem. Now, with two-factor authentication, your trusted device, well, actually all trusted devices at the same time, receive a push message that is saying, boom, someone is trying to log in from a new location or from a new device. Do you approve or not? If you do not approve the attempt, it will be canceled. So if you see an unusual pop-up asking you that someone is signing in, attempting to sign in, and it's not you, you can simply cancel it. It's interactive prompt. Now, if you confirm the prompt, you are displayed a 6-digit single-time password. You must enter that password into a prompt on that device that you're trying to sign in from. So that's a pretty secure and a pretty convenient scheme. Now, a major difference in security between this and the older scheme is two-factor authentication is in a secure delivery mechanism. You can only react to the prompt saying yes or no, and you can only see the one-time password if you unlock your device with a passcode or fingerprint. This alone makes it much more secure than two-step verification. Another thing, with two-step verification, if you're trying to log in from a new device, you can choose how you want to receive your code. You can choose to deliver it to one of your trusted devices, not all of them, just one. Or you can choose to receive it by a text message or a phone call, in which case, with two-step verification, the user will not be notified about the login attempt. With two-factor authentication, the first thing Apple does is send you notifications on all of your trusted devices. You will see, and that's inevitable, you will see that someone is attempting to log in. And you will be able to decline that. This is really important. However, Apple still kept a weak link here. It still allows you to keep SMS verification. So this new method is still susceptible to the same type of attack as the previous one. An attacker may clone a SIM card, use a fake power of attorney, or just pull the SIM card from a secure iPhone and use it in a different device, like a dumb phone, to receive an SMS. Which is worse, Apple requires you to verify at least one phone number. You cannot enable two-factor authentication without verifying your phone number. So this is a deliberately weak scheme here. You must protect your SIM card. If you travel with your phone and your SIM card and it gets stolen, then you know what to do. You have to cancel that phone number beforehand. Two-factor authentication also has application-specific passwords. You can generate and revoke them from your Apple account. In addition to all that, two-factor authentication uses an offline TOTP protocol. This is pretty much standard for all the other two-factor authentication methods. However, Apple does not reveal the seed. It doesn't reveal the secret. It doesn't give you the QR code that you might be able to scan. Instead, the seed is pushed to a trusted device directly from Apple Cloud servers. If you have multiple Apple devices, like several iPhones, iPads, a macOS device, then each device will be initialized with a unique seed, and each and every of them is revocable individually. This is very important because this is not the case with other authentication providers like Google or Microsoft. So with Apple, they keep it within the Apple ecosystem. You cannot install an authenticator app on your Android device and use that to generate codes. You have to use your iPhone. Even if it's offline, then you will go to iPhone settings, passwords and security, get verification code, and boom, you're getting the same OTP code, 6 digits. It's pretty much the same, but you can only use your iPhone, iPad, iPod Touch, or macOS system. And this is how the Apple ID verification code looks like. Now, as I said, you can still use app-specific passwords with Apple's two-factor authentication. It works, it's easy. There are two types of app-specific passwords. So there are two types of app-specific passwords you can use with Apple's two-factor authentication. Type 1 is the proper app-specific password you generate from your Apple ID from a web page, basically. It's just a 16-character password that uses all lowercase letters, no digits. This is very restricted. You can only use that to check your mail with IMAP, for example. And you can't do much more with it, honestly. Now, the second type of app-specific passwords is more interesting. With this type of a password, you receive a single-use code, a 6-digit code, and you attach it to the end of your real password. Now, when you do that, the combined password can be used to access all of the Apple services, including iCloud backups, iCloud photos, downloads, everything. So you can do that from devices that do not support two-factor authentication, like iOS 8. You can use an old iOS 8 device with this type of password. You can initialize it, restore from backups, make purchases from iTunes, Apple Store, whatever, with this type of app-specific password. There is no printable recovery key anymore. So if you lose your device and your trusted SIM card, and you are on the go, so you cannot immediately replace any of those, you have to go to Apple's website and attempt to reinstate access to your account, which is a complicated process. It may take up to 2 weeks. They don't make it easy. For this, it's recommended to maintain at least 1 credit card in your Apple account. If you are able to verify your credit card number, the recovery process is much faster. Now, two-factor authentication with Apple protects everything. Every time you try to sign in to any service using the Apple ID, you are asked for a secondary verification code, unlike the previous scheme, two-step verification. In order to access and confirm the prompt, you must unlock the device with a proper passcode or Touch ID. And that's why some researchers claim that this scheme is 3-factor authentication. The third authentication factor is being your fingerprint or device password. I do not necessarily agree with that, but it's a pretty secure scheme. We already covered the SIM cards. And as I said, revoking trust status from iOS devices is pretty easy. Each iOS device is revocable individually. You can do a factory reset. You can use Find My Phone to lock the device, after which it will no longer receive push notifications. You can remove the device from your Apple ID account online. You can remove the device from iCloud. You can block iCloud services from the device itself, in which case it will no longer receive these notifications because they are delivered through the iCloud protocol as opposed to Find My Phone protocol. You can remove a trusted phone number, after all. So you must add one, but you can remove it later in the settings. Now, it's possible to hack even this scheme. For example, hacking two-factor authentication, you can just extract an authentication token from the user's PC or Mac if the user had iCloud Control Panel installed and they logged in at least once. If that's the case, there is an authentication token, a binary file that's created. You can extract it and use it instead of the login, password, and the secondary verification step. That's pretty easy. Now, in two-step verifications, as I said, codes were displayed on locked devices. This no longer happens with two-factor authentication. However, if you gain access to the victim's SIM card, and that SIM card is active, you may be able to order a secondary verification code sent to that SIM card. Now, the user will receive a prompt, an interactive prompt on their device, and they will be able to decline this request. However, with proper timing, like in the middle of the night, it won't notice. So, how can one protect themselves from these types of exploits? Well, monitoring security alerts is one thing. Using Apple Configurator is another thing. With Apple Configurator, you can set up your iPhone to be as secure as you like. You can restrict the number of devices receiving these alerts. You can remove your SIM card. You can remove your trusted phone number. So you can configure it as you like. So the conclusion here: Apple's two-factor authentication is a modern, secure scheme. Apple wanted to keep it within their own ecosystem, and they did it that way. So it's pretty unbreakable, with few exceptions. Now, there are additional resources, and you may access them if you download this presentation. You can check Apple knowledge base articles. You can check our own article in our blog. We have everything. So, any questions regarding Apple two-factor authentication schemes? Yes?
One thing that I think is often missing from the discussion of Apple's initial two-step verification is that they were designing it so that they did not have the ability to unlock or recover your data. So it was actually a cryptographic system using secret sharing. So you use secrets that are either embedded in your devices or derived from your password or from an application key, and you cryptographically require at least two of those to be able to actually decrypt your encrypted data on iCloud. And so this is why those things that were just available through the website were not covered by it.
Right.
If Apple could decrypt it to be able to display it to you.
Okay, so let me rephrase it. In a word, it's incorrect. So the question was whether or not Apple was designing this two-factor authentication system in order to keep things secure, encrypting data so that's encrypted with a key derived from both the password and the secondary authentication code. Is that correct?
Yes.
No. This is not correct. Because using our tools, we were able to download iCloud backups and decrypt them with keys that are stored in the cloud alongside with the main backup. These keys are not changed if you change your secondary authentication factor. In fact, these keys do not change if you change your passwords, your account password, whatever. So Apple does not really encrypt any data because they have full access to all information that is stored in iCloud. We can prove that. So if a law enforcement entity makes a request to Apple, give us the data, they supply all the data from iCloud decrypted. They don't need your password. They don't need your secondary authentication codes.
Just because keys don't change, remember that there's going to be a set of key encryption keys.
The keys are stored alongside with the main backup. They are accessible to anyone, including Apple, law enforcement, us. That's the point. There is no point in encrypting data stored in iCloud. Now, data encrypted in the device itself is a different matter. It does not depend on secondary authentication codes as well, but it's much more securely encrypted. Yeah. You're welcome. Any more questions about Apple's? No. OK. So let's go to Google Android. And the first thing I must say, we are discussing Google Android as opposed to Android per se. Because it's Google with its Google Cloud Messaging that is slamming secondary factor authentication on top of Android. AOSP Android does not have any of that. Absolutely not. So, talking about Google. We'll speak about what's protected, TOTP and GCM push notifications, non-compliant apps, and revocation. So, initially, when Apple started protecting your Google ID with secondary authentication factor, they only used TOTP, time-based one-time password algorithm. This scheme is probably well known to all of you. Basically, a trusted device is initialized with a seed, and in Google's case, it's just a single seed to initialize all devices. It's transmitted to your device in a text form or as a scannable QR code. You may scan the QR code with as many devices as you like. They will not be individually revocable. If any of your trusted devices is compromised, you will have to revoke the complete secret, immediately invalidating TOTP codes generated by your other devices. That's the major difference between Google's implementation and Apple's implementation. Google also has a GCM push, and we'll talk about it later. App-specific passwords, very similar to Apple. They only allow restricted access to certain Google services. They do not allow major takeouts via, say, Google Takeout. You have printable backup passwords that are also known to many European visitors here because they're banks used as TAN lists, transaction authentication numbers. So they're printable, single-use passwords. Voice to text message, similar to Apple, but you don't have to verify your phone number in order to activate two-factor authentication. And finally, a security key, which is a digital key you can insert to your laptop, and then the secondary authentication will be provided to the Chrome browser and nothing else. So, what's protected? Google offers a pretty extensive protection with two-factor authentication. It's similar to Apple's two-factor authentication. Every login to Google services like Gmail or Google Takeout or Google Calendar, Google Drive, anything prompts a secondary authentication factor. It's pretty good here. There is an exception here. A secondary authentication prompt does not show up if you are setting up a new device, a new Android device that is initialized with an NFC chip in one of your existing devices. So if you just do it back to back, no secondary authentication prompt, no password. So as I said, there is an extensive number of verification options available. Let us start with TOTP. So time-based one-time passwords work securely offline. Every 30 seconds, a new 6-digit password is generated. You can generate these passwords in any authentication app. You can use Google Authenticator, Microsoft Authenticator, Xiaomi Authenticator, open source authenticators like Yandex or OTP Authenticator, whatever. There is a huge number of authenticator apps available on all major platforms. Google, Microsoft, Ubuntu, iOS, anywhere. They are universal, interchangeable. Go ahead and feel free to use any of them. Most of them are secure. Now, the seed is delivered as a QR code that can be scanned by any device. If you want to initialize a new device and go to your Google ID settings and prompt for a QR code, the previous QR code will be invalidated and all your previously trusted devices will no longer work. So if you want to initialize more devices with the same seed, you may just be able to save the QR code for future use. That works. As I said, revoking this kind of authentication can only be done for all devices at once. They are not individually revocable, unlike Apple. OK, so we already talked about that. What about security? How secure is TOTP authentication? Now, I'm not discussing the TOTP protocol by itself. It's an open standard. It's pretty secure. Let's talk about Google. Let's talk about Android. Android is not a secure system. For example, if you have root access to your phone, you can just extract the Authenticator app data, and you can use that data to initialize a new authenticator from a different phone. If you don't have root access, but the device comes with an unlocked bootloader, which is the case for many MediaTek phones, all of them come with unlocked bootloaders that cannot be locked by the user, then you may be able to boot into a custom recovery and still extract Authenticator app data and use that to initialize a new authenticator. There are also backup tools provided by many device manufacturers such as Sony, Asus, LG, whatever. You can create a backup, including all applications. These backup tools generally ignore whatever application permissions there are. They just back up all of the data, and you can use those to restore Authenticator app data and use that as well. So we discussed TOTP. Now, there is another and more convenient two-factor authentication scheme available with Google Android. It only appeared recently, like in the last 3 or 4 months. They call it Google Prompt. Google Prompt is just a message that appears on your trusted device, a trusted Android device. It's a simple yes or no message. It only connects through Google Cloud Messaging. It goes through Google servers. So if you're trying to sign in from an unusual place, or you're trying to sign in from a new device or a web browser, you get a Google Prompt on your Android phone. It will ask you, do you approve the sign-in request, yes or no? If you push yes, there is no code displayed. You immediately authorize sign-in. Google Prompts are delivered to all of your trusted devices at the same time. Google Prompt is delivered through Google Cloud Messaging. It does not depend on the version of Android. It works with Android 5, 5.1, 6, 7, 7.1. We tested all of that. A major thing here is that Google Prompt requires the latest version of Google Play services installed. And Google Play services are updated separately from Android versions. So most users, most customers have the most recent version of Google Play services already installed. What if you are configuring a new device? Will you get this prompt? Yes, because every Android device, starting with Android 5, when you set it up, it will automatically update to the latest version of Google Play services during the setup, and then you will receive this prompt. So as I said, it's a new implementation. It works via Google Cloud Messaging, available on Android and iOS. On iPhones, all you have to do to activate Google Prompt is installing the Google app. Once you install the Google app and sign in, you will be able to configure it to receive these Google Prompts. Google Prompt can only be confirmed or declined if you unlock your device with a password or a fingerprint reader or whatever. Now, why I'm saying that, it's not obvious because Microsoft is not doing that for Windows 10 Mobile. And more on that later. So setting up a new device for Google Prompt is pretty straightforward. You just confirm that the device is a trusted device. You are prompted to use Google Prompt on that device, and boom, you're done. You can also enroll your devices to use Google Prompt from Google account settings to factor authentication online from any web browser, so you do not have to use an Android device or an iOS app for that. You can revoke any individual device enrolled to Google Prompt. You can do that by either logging into your Google ID online with any web browser, or you can do it from the device itself, or you can do it with Android Manager by just locking the device. So it's pretty convenient. I think that this method is more secure than TOTP for obvious reasons. You cannot, well, technically you can, but you should not be able to move Google prompt confirmed status by just cloning the device memory. However, you can still do that. It's a rare exception. Google prompt is not tied to a hardware-based ID. Instead, a unique random number, a unique random identifier is generated every time you initialize a new device. Attacking a Google prompt is possible if you use a custom recovery and make a full Nandroid backup of the device. Restoring that Nandroid backup onto a new device of the same make and model will clone the entire device, and the new device will receive the Google prompt, as well as the TOTP-based authentication will work. So that's only specific to Androids. You cannot do that on Apple devices. You cannot do this on Windows 10 mobile devices. However, with Android devices, it worked. I tried. OK, app-specific passwords, not much different from Apple. There are 16 characters, all lowercase letters, restricted use for, say, accessing email. Backup codes can be printed. They are nicely formatted as a credit card size. You receive 10 codes. They're single use. You may use them later. If you travel a lot, I recommend printing them and keeping them in your wallet. It helps tremendously if you lose your phone with a SIM card. Unfortunately, Apple does not offer you this option here. Google does. They do not expire, by the way. These printable backup codes do not have a set expiration date, so you can use them a year later. You can revoke all of them or the rest of them at any times by printing another set of 10 codes. You can also use a SIM card or a phone call for authentication. However, unlike Apple, you do not have to do that. It's optional. Finally, you can use a FIDO Universal Second Factor UTF devices for two-factor authentication in Google Chrome. Yes. OK, so 5 more minutes. OK, so we discussed Google. Now, let me quickly because it's not a very popular platform, talk about Microsoft. So Microsoft also uses TOTP and cross-platform push on all major platforms, including Android, Windows 10 Mobile, and iOS. Signing into your Microsoft account from a new IP address or a new device or a new web browser always triggers a prompt for two-factor authentication. TOTP authentication is very similar to what you've already seen in Apple and Android. However, the push notification prompt is kind of different. It's similar to Google prompt in that it's a simple yes or no notification. So the secondary authentication factor is done on Microsoft Cloud services. However, in Android and iOS, you must unlock your phone or tablet to confirm Microsoft account sign-in. In Windows 10 mobile devices, the prompt appears on top of the locked screen. So you can just push yes without unlocking your Windows 10 mobile device. And that, I consider that to be a major security flaw with this implementation. Now, TOTP is similar to Google in that you get a single QR code you can scan to generate 6-digit codes. However, in addition to that, you can also initialize Microsoft's proprietary Microsoft Authenticator app, available, again, on Android, Windows 10 Mobile, and iOS. If you initialize a Microsoft Authenticator with TOTP protocol, every 30 seconds you will receive a unique 8-digit password, as opposed to 6-digit password. And if you do that, each authenticator app will be initialized with its own seed, individually revocable. 6-digit and 8-digit passwords are interchangeable. You can use any of those at any time. And that's pretty much everything. I have a lot more to say about Microsoft, recovery codes, links, and everything. If you are interested, you're very welcome to download the presentation. I also uploaded a PDF file, a pretty large article that explains everything that I said here in more detail. So you're very welcome to download that after the conference. And if you have any questions, please feel free to ask.
No questions.
OK.
Thank you.
Thank you, guys.